Welcome to our presentation on the key differences between TensorFlow and PyTorch. In the next few minutes, we'll explore 8 fundamental differences between these two popular deep learning frameworks. This interactive presentation will help you understand which framework might be better suited for your needs. Let's get started. The first major difference lies in their computational graphs. TensorFlow uses a static computational graph, meaning you define the entire graph first and then execute it. PyTorch, on the other hand, uses a dynamic computational graph that is defined on the fly. This fundamental difference impacts how you write and debug your code. When it comes to API design, TensorFlow offers multiple APIs including Keras and Estimator, which can make it more complex to learn. PyTorch, however, provides a more Pythonic and intuitive API that many developers find easier to work with. This difference in design philosophy affects the developer experience significantly. Debugging is another area where these frameworks differ. In TensorFlow, you often need specialized tools like TensorBoard for effective debugging. PyTorch, however, allows you to use standard Python debugging tools such as PDB or simple print statements. This makes the debugging process in PyTorch more straightforward and familiar to Python developers. For production deployment, TensorFlow has a more mature ecosystem with TensorFlow Serving, TensorFlow Lite for mobile devices, and TensorFlow.js for web applications. PyTorch has been catching up with tools like TorchServe and TorchScript, but TensorFlow still has an edge in production environments. The communities around these frameworks have different strengths. TensorFlow, backed by Google, has seen wider adoption in industry. PyTorch, backed by Meta, has become the preferred framework in academia and research. This means you will find more research papers and tutorials using PyTorch, while TensorFlow is often chosen for large-scale production systems. When it comes to visualization, TensorFlow's TensorBoard provides comprehensive visualization capabilities for monitoring, training, and understanding models. PyTorch can integrate with TensorBoard but has fewer native visualization tools. This makes TensorFlow more appealing when extensive visualization is needed. The learning curve is another important consideration. TensorFlow generally has a steeper learning curve because you need to understand concepts like sessions and placeholders. PyTorch is often considered more beginner-friendly because its API is more intuitive and closer to standard Python programming. Finally, for mobile and edge computing, TensorFlow has a significant advantage with TensorFlow Lite, which is well established for deploying models on mobile and edge devices. PyTorch Mobile exists but is less mature. If your project involves deployment on resource-constrained devices, TensorFlow might be the better choice.